calculate the total distance that's traveled by p over the time interval, 0 to pi, we have to be clear that we are finding the total distance. And we have to remember that distance is the absolute value of positioning. Okay, so we need the absolute value of that, the change in the position. So to do that, we need to calculate the positive displacement, which would be above the curve, and we need to calculate that separately from the negative displacement below the curve. Okay, and to do that, we need to know the boundary point, which is the 0. So that's the first thing we're going to do. We calculate the 0 value of this curve, and we calculate the 0 to be at 2.1450, and then we use that as our bound. So when we calculate that red area here, so this would be the displacement, the change in x of p is going to be equal to 0 to 2.1450 of our v of p function. Okay, and when we find that out, work that out, that works out to be positive 1.2232. So we've gone in a positive direction. Okay, but the actual distance traveled, we just take away the positive and we just end up with the absolute value, which is going to be 1.2232. And then we do the same for the other portion here, but this is going to then become a negative displacement. So this, in this case here, becomes a negative displacement of negative 0.7083. So when we work that out, the change in p from 2.1450 to pi of this velocity function, we end up getting a negative value of negative 0.7083, and then but we want to find the distance traveled, so we take the negative out of that and we end up with that. Okay, so then the total distance traveled, the total distance is going to be, when we add those two values together, so I get 1.2232 plus 0.7083, and we get a total distance traveled of 1.9315 units. Okay, in this case, I think it's meters.